All right, so not an ideal time to be doing videos because it's a bit noisy in the background, but I want to work through a couple of questions with synthetic method specifically because we had just introduced it. So, the more practice we get, the better. All right, so 3 questions, and I want us to work through these questions. I'm going to start with our very first question. Let me get my pencil sorted, as is usually the case. All right, we should be okay now. And the first question is x cubed plus 5x minus 6 divided by x minus 2. All right, so this is our divisor. Our dividend is here. But what you notice about the dividend is that it is not written in such a way as to have a sequence or descending sequence of powers of x. So it moves from x cubed to x to the first, right? And that means that we don't have a power in x squared. So for this type of question, it would be better if we acknowledge that we're actually dividing x cubed plus 0x squared plus 5x minus 6. All powers of x must be represented. We're dividing that by the x minus 2, right? With this step in place, we should be able to resolve this issue. And our first step is going to be, let's find our root. And our root is going to occur where our divisor is equal to 0, which implies that in this case, x is equal to 2, right? Now, what that means is that we have our 2 here. We're going to go through our process, right? And we're going to write down our coefficients. And our first coefficient, of course, for x cubed is 1. X squared is going to be 0. X is 5. And our constant is negative 6. Now, we know the process. We're going to bring this 1 down. But then we're going to multiply and add. Multiply by 2. And we're going to add. So we get 2 here. Multiply by 2. And we're going to add. We get 9 here. Multiply by 2. And then we're going to add, and we should get here what looks like 12, right? Now, we're almost done. Remember that we divided a term in x cubed by a term in x, so this very first coefficient is a coefficient of x squared. So we should end up with then 2x plus a constant of 9, plus this term here, the last term is always your remainder, plus 12 over x minus 2. And that's the solution for that question. All right. So hopefully that's what you're getting on your end, because the process doesn't really change. It's more of the same, right? Again, we can use the synthetic method easily, given that the coefficient of x in the divisor is 1. All right, let's look at another question, right? And I don't want to kind of have everything side by side like this, but let's see if this, we don't making too much of a mess. Hopefully this is clear. So here we have, for our next question, this is number 2, 2x to the 4th minus 3x squared plus 5 divided by x minus 1, right? So this is our divisor here. This is our dividend, but again, we realize that we don't have that proper sequence of powers of x in our dividend. So we can rewrite that dividend to read 2x to the 4th plus 0x cubed minus 3x squared plus 0x plus 5 divided by our x minus 1. That's what we need in order for this to work, right? Now, if that's the case, let's find our root, which is our first step, or 0, depending on how you want to phrase that. And we find that by making x minus 1 our divisor equal to 0, which implies therefore that x is equal to 1. And if that is true, we have our 1 here, and our setup here, coefficients only 2, 0, negative 3, 0, and 5. Right? Now, bringing down that 2, and we're going to multiply and add. So multiply by 1, we get 2, we add. Multiply by 1, we get 2 again, we add. Multiply by 1, oops, that's a 1. Ooh. All right, I am forcing myself to erase this because that should be a 1 and it looks like something else. But let's see if we can get that erased really quickly. I need it to look like my 1. All right, cool. We're on the right page with that. Let's see if we can get back to where we're at. Multiply by 1, we get -1. Here, multiply by 1, we get -1, and this should be a 4 here, right? Now, remember that we divided a term in x to the 4th by x. So the first term should be x cubed, then we get x squared, then we get a term in x, and then a constant, and the last term is always our remainder and is written over our divisor. All right, so we're comfortable with those two, right? That should have been practice for you. And I'm going to do one last one before we call this a day, right? The third one that we're going to have a look at is x to the 5th minus 32, all divided by x to the -2. That's our divisor. At this point, you've picked up and you have the gist, right? Once you have missing powers of x in your polynomial, you're going to actually fill them out with placeholder values, right? So instead of x to the 5th minus 32, we're going to write that our dividend is actually x to the 5th plus 0x to the 4th plus 0x to the 3rd. You know what's happening? Plus 0x squared plus 0x minus 32, all divided by x minus 2. And we're on the same page now. Again, first step for us is now our root, which occurs when our divisor is equal to 0. And that implies that it occurs when x is equal to 2, right? We're all in the same place. That was a straight line. I'm very impressed with myself there. Now we're taking the coefficients of our polynomial. So we have 1, 0, 0, 0, 0, and -32 for our constant. Hopefully I didn't miss anything there. So we should have 4 zeros, the 1 and the -32. 1 being the coefficient of x to the 5th. And of course, we start there, pull this down, and in this process, the syntactic process, we're just going to multiply by this term here by our root, which is 2, and then we're going to add. So we're going to get 2. Multiply by 2, we get 4, and we add. Multiply by 2, we get 8, and then we add. Multiply by 2, we get 16, and we add. Multiply by 2, we get 32, and we add. So for this very last one, we happen to have 0 as our remainder, which suggests explicitly that x minus 2 was actually a factor of the polynomial, the initial polynomial x to the 5th minus 32. And that's fine, right? So what we're going to do here, we're going to remember and acknowledge that we divided a term in x to the 5th by a term in x. So this first coefficient applies to a term in x to the 4th. This one, x cubed. This one, x squared. This one, x. And that one is just our constant. And again, we have no remainder because x minus 2 happens to be, in this case, a factor of x to the 5th minus 32. All right, so I am going to call it a day there. Hopefully you'd have had an opportunity to pause at each question, work ahead of me, resolve the answers, and you're comfortable. If you have any issues, of course, there's always a comment section. You can let me know. But again, don't forget to like and subscribe, and we'll try to continue to put out the content that will help you to get an understanding of not only algebra by and large, but for now, specifically polynomial division and the syntactic method.